Alright, okay, let's solve this question. This question is asking us to prove that the line neither cuts nor touch the circle. Means that the line, okay, then this is a circle, right? The line can be cross the circle, right? Or we said cuts the circle, right? Cuts the circle definitely is 2 point, right? So for this case, definitely if you solve the simultaneous equation between the line and the circles, you are getting a quadratic equation. Because why? Because at most the line at most can cut the circle at 2 point, right? So you can get a quadratic equation. So, but if the quadratic equation, if you're using discriminant to verify it, if you're getting something that are positive to discriminant, then we show that it cuts the circle, right? So when the circle, let's say if you touch the circle at a point, right, means it's also intersecting the circle, but it touches the circle at a point, right? So then we say that they have solved the simultaneous equation, the quadratic equation having one real roots, okay, one equal real roots. Though then we have equals to 0 because they intersect at one point. Or maybe the line do not intersect the circle, right? Do not intersect means that there are no roots. If you finding the equation, solving the simultaneous equation between these two, the line and the circle, you're getting a quadratic equation. The quadratic equation does not have real roots, right? Which means that b squared minus 4ac less than 0. Okay, this is the case here. So by looking at this question, right, they prove that the line neither cuts nor touches the circle. Means that it's not cuts the circle, not intersecting the circle, not cuts the circle, and also not touch the circle. So means that they wanted to prove that it's this case here, right? It's neither means not cutting the circle and also not touch the circle at the same time. All right. So how to proving this? Very simple. So you just need to solve the simultaneous equation between this line and this circle. So we have substitute this one, y equals to x plus 3 as equation 1 for the line and equation 2 for the circle. So we substitute, we have x squared plus with y squared, x plus 3 to the power of 2 minus with 6x plus with 8y. Y is x plus 3 minus 7 equals to 0, right? Solving the simultaneous equation. So I substitution method, I substitute x squared plus with 6x plus with 9 minus with 6x plus with 8x plus with 24 minus with 7 equals to 0, right? Okay, you're getting the quadratic equation. X squared, you have 2x squared, right? You have 2x squared. 6x minus 6x, definitely you were getting 0. So positive with 8x. So then you have 9 plus 24. Alright, 9 minus 7. 9 minus 7, you have 2. Then plus with 26 equals to 0, right? Okay, 9 minus 7, you have 2. 2 plus with 24, you have 26. So divide everything by 2, right? Divide everything by 2. So you will have x squared, right? X squared plus 4x plus with 13 equals to 0, right? So this is the equation. So before we solving the equation, right? Before we solving the equation, so we can using this quadratic here to identify which of the case here, right? So then we're using this is your A is 1, your B is 4, and your C is 13, right? The coefficient of x squared, x, and the constant. So then we calculate, we're using b squared minus 4ac discriminant to verify the roots of this equation, right? Types of roots of this equation, of this quadratic equation. So b squared, which will be 4 squared minus 4a, a will be, and c will be 13. So you're getting 16 minus with 4 times 3, right? 4 times 3 is 22, 414, 52, right? So 52. So definitely you were getting a negative number here, right? You were getting you're getting a negative number of negative 36. You're getting negative 36. As long as you get a negative number, this shows that this quadratic does not have a real roots. This already show that the simultaneous equation between this line and this line and this circles show you that this is the case here, right? Have verified that this circle is neither touch nor cuts the circle, right? It's already proven. You just do a statement, right? By because b squared minus 4ac, the discriminant have verified that is in the negative, right? It's negative. So then you can telling that the line do not intersect the circles because the quadratic does not have real roots. Alright, that's all for this video.